the natural progression from multiplication will be division. And that's the last type of operation that we'll learn how to perform with polynomials. So most of the time when you see these problems, you will see a big fraction with a polynomial on the top and either a binomial, a polynomial, trinomial, monomial, or just one variable on the bottom of the fraction. So the goal here is to simplify the top in such a way that perhaps it will allow us to get rid of the fraction. And what I mean by that is kind of cross out whatever we have on the bottom by factoring the top. So if you have been paying attention, you notice that the top of the fraction, the numerator, kind of looks like a perfect square, right? It kind of looks like a plus b squared. And that term is x plus 2 squared. You can also see that we have x plus 2 on the bottom. So let's expand the top and say x plus 2 squared is equal to x plus 2 times x plus 2. And on the bottom, let's just write x plus 2. So that way we can cross out these two and be left with just x plus 2. Okay, so in this case, we were working with a perfect square, which is fairly simple to factor out and fairly simple to break it down into simpler components. But that won't always be the case. Here, in the second example, we do not have a perfect square. So we are going to use the AC method. So A is 1, B is 7, and C is 12. We are going to do our cross, put A times C on the top, which is 12, and 7 on the bottom. So we are looking for two numbers that will be factors of 12 and multiply to 12 and also add to 7. And I think that's 3 and 4. Once again, if you're not able to find these factors right away, just list all of the factors of 12 on a side, and sooner or later you will arrive at a correct answer. Okay, so now let me actually copy it right here since we drew the cross on the right side. Let us expand that positive 7x in terms of 3's and 4's. So we have x plus 3x plus 4x plus 12, and the bottom remains unchanged. It's 3 plus x. Okay, now we're going to factor out some more things by grouping. So from the first group, let's factor out x. And we are going to be left with, we're going to have x, and we're going to be left with x plus 3. You can already see where I'm going with this one. Okay, from the second one, let's factor out 4. And we are left with x plus 3 again. Once again, the bottom remains unchanged. It's x plus 3. And before we simplify this fraction, let us factor out once more. So let's factor x plus 3, x plus 3, and we are left with x plus 4. And on the bottom we have x plus 3. Therefore, we can cross out x plus 3 and x plus 3 from the bottom, and we are left with only x plus 4. All right. In the next case, we have two binomials. that are divided, and we'll have to do some more work before we can simplify this fraction and obtain the final product. So I want you to ask yourself, what can I do to the top so I can factor out something at the bottom? Or perhaps can I do something to the bottom that will help me simplify the top? Well, 3x is indeed a factor of 9x squared, and 2 is indeed a factor of 8. So why don't we factor out 3x plus 2? So 3x plus 2. And then when we divide it, right, we will end up with 3x plus 4. And when you FOIL this out, you will end up with exactly the same thing we started with. And in this case, that was fairly simple. We can cross it out and we can say, oh, this is just 3x plus 4. And we are done. So the goal with dividing different polynomials is to always simplify by factoring, and then you will be able to cross out certain things. Most of the time, in many of the problems that you will be working with, the denominator will be a factor of the numerator. So your goal is to simplify the top of the fraction as much as possible by factoring, by using AC method, by using the perfect square formula, and that way you will be able to obtain the final answer.